All right, today we are looking at lesson 9.4, rational numbers. So our learning target today is to be able to convert between different forms of rational numbers. I can explain the meaning of a rational number, I can write fractions and mixed numbers as decimals, and I can write repeating decimals as fractions or mixed numbers. So first, we want to remember that a rational number can be written in the form a over b, or as a fraction, okay, where a and b are integers, okay, and the denominator b cannot be 0. Every rational number can be written as a decimal that will either terminate or repeat. Okay, terminating means the decimal will stop. Repeat means that it has some sort of pattern, okay, that is repeating over and over. A rational number that can be written in the form a over b, right, a is an integer and b is a power of 10, has a decimal form that terminates. Okay, so then you'll know if it's going to repeat or terminate. All right, so if we were looking at the first example here, it says write 1 and 4/25 as a decimal. So if I was going to change this problem to a decimal, the easiest way for me to think about it is first I'm going to change this to an improper fraction. So if I made it an improper fraction, that would be 29 over 25. Right, then I'm going to get my denominator to 100. So I'm going to multiply by 4 to both the numerator and denominator to make this as 116 over 100. And then this I can change to a decimal, which would be 1.16. Okay, you also could have done that same thing, right, with just the 4 over 25, right, by multiplying that by 4 to get 16 over 100, and then you could have added the 1, so 1 and 1600ths. Okay, that would be another way to look at it. Okay, for the next problem, write 5 over 33 as a decimal. So this one, I cannot get the denominator to 10 or 100, right, any power of 10. So for this, I'm going to have to use long division. So remember the top number always goes inside, right? The 33 goes on the outside. 33 does not go into 5, right? So I can write my 0, can add my 0 in. 33 goes into 50 once. Right, we subtract, we get 17. Okay, add my 0. 33 goes into 170 5 times. Right, you get 165. Right, when you subtract, you get 5. Okay, it doesn't go in, you get 0. Right, add our 0, goes in once, you get 33. Subtract, you get 17. Add your 0. Okay, it goes in 5 times. Right, you get 165. Subtract. Okay, you get 5, right? You're going to notice that this pattern repeats. Okay, so my answer would be 0.15 with the 1 and 5 both repeating. Okay, so that repeating sign goes over both pieces. All right, so now let's try some of these. All right, so if I was looking at 3 over 15, okay, the first thing I'm going to do for this problem is I'm going to simplify this. 3 over 15, I know is equivalent to 1 over 5. Okay, so why does that help me? Because 5 is going to go into 10 or 100, right, really easily. So if I had 1 over 5 and I multiplied by 2, I get 2/10, which is 0.2. Oops. All right, if I was looking at that next one, negative 2/9. Well, here, right, negative 2/9, again, does not go in easily. So I am going to do long division. So 2 goes on the inside, right? 9 goes on the outside. 9 does not go into 2. Remember, my answer is negative, right? So I'm going to include that right away. So negative 0. I'm going to add my 0. 9 goes into 20 twice, right? That would give me 18. Subtract, I get 2. Okay, and then you'll notice that this pattern is going to repeat. Right, so we can continue on with that pattern. So my answer, right, would be negative 0.2 repeating. Okay, same idea for the next one. Right, 4 and 3/8 does not divide nicely. I'm going to change that to an improper first. So that would give me 35 over 8. Okay, so if I divided, 8 goes on the outside, 35 goes inside. and 8 goes into 35 4 times, right? That would give me 32. Subtract, we get 3. 8 does not go into 3. Add my decimal, add my 0. 8 goes into 30 3 times. That would give me 24. Subtract, add my 0. 8 goes into 67 times, right? That would be 56. Subtract, add my 0. 8 goes into 45 times. All right, so my answer for that one is 4.375. Okay, last one. Again, this doesn't divide evenly. I'm going to make it improper. That would become 28 over 11. Okay, so 28 goes on the inside, 11 goes on the outside. We do our long division. 11 goes into 28 twice. Subtract, add our 0, and our decimal point. 11 goes into 65 times. Subtract, add my 0. 11 goes into 54 times. All right, and now you're going to notice, right, this bottom pattern repeats because we get 60 again, then we would get the 5 again, right? Then you're going to get the 4 again, and so on. So my answer would be 2.54 with the 5, 4 repeating. All right. We are actually going to stop there for today. So go ahead and log into Big Ideas and try those problems.